Hello everybody, this is Alex Voss, and we put out a video a little while ago asking for suggestions on what you would like us to do as far as our training classes go. And one of the suggestions was, let's do one on CAD. And so we're going to start a series on CAD. And CAD means computer aided drafting. And it can be done in all different kinds of ways. I'm going to focus on computer aided drafting CAD for electronic applications, how to do schematics, how to do block diagrams. And we're going to start out simple. We're going to use a software that you have on your computer right now, most likely. We're going to use Microsoft Paint. Now, Microsoft Paint has been around on every Windows computer, and it has a counterpart on the Mac computers called McDraw and McPaint, which you can get and put on your Mac computer. These are bitmap programs, and you can do CAD on a bitmap program. Now, more typically, we do CAD today with vector-based programs, and you can buy a vector-based program. They're relatively expensive, most of them, and they have a big learning curve. But to get you on the road, going real quick, we're going to start off in Microsoft Paint, and I'm going to show you the power of Microsoft Paint for CAD. And once you learn the techniques on Paint, we're going to do a few more classes on the more advanced forms of CAD on vector-based CAD applications. But you can start right along with me. I'm going to do several classes, one on how to draw components, then how to draw a schematic diagram, and then we're going to go through all of that, and then I'm going to go into a block diagram in the Microsoft Paint, showing you how to do electronic circuitry on CAD using Microsoft Paint, which is a program you have, and you can start and you can work right along with me. Pause my video and do what I showed you to do in the video on your own computer, and we'll learn by doing. We're going to learn how to draw components. So we're going to open up by clicking on Paint, and I'm going to file and I'm going to save as components. So I saved it as components bitmap. And one of the first things I want to draw is a transformer, and it's one of the most difficult. Getting the coils on a transformer is one of the hardest things to do in any CAD program. After lots of experimentation, I found that if I drew a bunch of circles, and here's what I made a mistake on, so I'm going to go back and get rid of this little dot down here eventually, and I'm going to draw another circle below this one. And so get all these circles drawn as best we can, and this is just a rough example. And then once all the circles are drawn, I'm going to go up to the select button, and then I'm going to cut them in half. Well, first we'll get rid of that dot, and I select, and I then cut these in half. And so once they're cut in half, we're going to have an example of a coiled schematic diagram, the kind you'd use for a transformer. And of course, since this is a laminated iron core transformer, we're going to draw these two lines here to indicate that it is a laminated iron core. The laminations, of course, are to prevent hysteresis. Now, I'm not worried about getting the lines perfect. My concern is just getting them appropriately next to one another, and then I can go up and I can use a select tool to cut off the ends, making them perfectly aligned with each other on the ends, just like I'm doing right now. And so we've got the primary and the secondary. Now notice the primary is a little too close to the core, so I'm going to move it out a little bit, and so that gives a little distance where you can see it better. But this is going to be a step down transformer, so I'm going to take and I'm going to copy a part of the coil, and then I'm going to copy it and I'm going to paste it, and then I'm going to drag it down to where it's supposed to be, but I'm going to have to invert it. So I go here and I go rotate, and I'm going to flip horizontal, and then we'll just put it in, and now we have a transformer. Now I have to attach the wires to the transformer, and this will be our transformer template that we can use for transformers as needed. And of course, you saw I just enlarged it where I could clean it up a little, and then I'm going to put some wires on the ends of each of the primary coil. And there's the top wire. I'm going to do the second, the bottom wire. And I'm not worried about the length of the ends, because I'll take care of that with the selection tool, and just, you know, make sure that everything's even. Okay, here's one wire on the secondary. Here's another wire on the secondary. So this is a step-down transformer. It could be the transformer you use to make a low voltage power supply, or the step-down transformer for a speaker, because you might be going from like 5,000 ohms to 8 ohms, and so you need a step-down transformer. And so here I'm cutting off the wires to make them even, and I'm also going to touch up that little spot with the eraser tool to make sure it's smooth. Then I'm cutting off the wires on the primary to make them even. And so now we have a nice template for our transformers. So we made our first and our most difficult one. The transformer has always been the most difficult for me to make in any CAD program. Now the reason we're doing this is so with, you know, Microsoft Paint, everybody has it that has Microsoft, but also, or, you know, Windows computer, but also if you have a Mac, there's McDraw and McPaint, which still is around, and you can use that. Now we're going to draw a diode. So here I'm drawing a diode by using the triangle tool, and then I'm going to just come in and put a line through the middle for the leads that go in and out on our schematic symbol here. And then I will take the paint bucket here and I'll fill in both sides. So there you are, a perfect schematic symbol for a diode. So there we have our second component made real quickly. I'm going to clean up the ends by cutting them out now, and then I'm going to go and what are we going to make next? Let's see. Pick a component. I'm going to go with a line here, and I'm going to draw a line straight up and down. So this is the beginning of a transistor. Now what we're going to do is we're going to put the base on our transistor. See how easy that is? You just connect it, and there's your base connection on the schematic diagram of the transistor. I'm having a little trouble getting it level, but I got it. And then I'm going to put the collector up here, and I want to put the emitter down here. And now we're going to put the little triangle on it. Well, first let's even them out. So see if I go to the selection. Oh, here I'm going up with the wire coming from the collector. And then we want to have the wire on the emitter at the same point, so I'm going to use a selector tool. Start up here to size it, go straight down and cut. That makes both of these wires the same size, and go get a wire and run down on it. Now on our emitter we've got to have a little arrow pointing out. Now how are we going to do that? Let's get our triangle, and then let's draw it out and see how it's pointing down on one end. So we'll take it down here and put it on the transistor. It's a little large, so let's resize it and recenter it the best we can. And so there's our emitter arrow, which means that's an NPN transistor, not pointing in. So now we'll put our circle around it. And so there's our schematic diagram for a transistor. I want to extend the input wire on the base a little bit. So here you go. Now you notice I drew this a little bit on the large size. So what we're going to do is I want to take this and move it over here, and we'll keep the large one. But let's just say we want a smaller one. Let's just copy it, and then let's paste it. And so we're going to take this one and we're going to shrink it by grabbing the corner and dragging it evenly down, and you have a smaller transistor. In Microsoft Paint, the only problem is when you shrink like this, you notice the wire size or the line size decreases. Now also you can go on the internet and you can get a lot of these components right off the internet, and instead of building them like I'm building here, we could make the components, we could just get the components off the internet and then use those for our basket of components that we're going to be using for all our future drawing projects involving electronic components. As you can see, I'm making a capacitor. And again, I'm not worried about the length of the wires because I'm going to use the selection tool to even it out. So I'll come in here and I'll draw around the area that I want, get it right, get it centered, cut off the ends to make them even. And then there you are, there's a perfect capacitor schematic symbol. Get rid of the leftover. Now, if you wanted to make this an electrolytic, I could put a plus on it. So I go down here to the text tool, and I'll just draw it. I'll type a positive symbol on my keyboard. Let's get it the right size. And so we're going to make a plus, and then we're going to click out of it so that we're back where we can grab it and put it on one side of the capacitor. So now we've made a symbol for a capacitor. Look how quick that was. Let's make some more components. Now, what we're going to do is when we make these components, we're going to do a few examples of how to do a schematic diagram using Microsoft Paint. And the neat part about Microsoft Paint is everybody has it. Now, look at what I'm doing with these triangles. This is, again, one of the hardest schematic symbols to make in Paint or in most any CAD program. Now, most people will go and buy these symbols or get them off the internet and use them in their schematics, or they'll pay a lot of money for a CAD program. And oh, I made a mistake here, so we'll get rid of that. But I'm showing you how to make one, for free. And so let's just copy this section because they all match, and then we can double up. Let's copy again. I didn't want to copy. Okay, so go select, copy. And then I'm going to paste, and then we'll connect them together. Now, are you figuring out what this symbol is going to be? I wonder. Let's get them evened up. Now, it doesn't. You can't tell what the symbol is going to be until you get the select tool and you cut off a part of it. So I'm cutting off this bottom line, and we're going to remove that section. And look what we have. We have a resistor, or the beginning of a resistor. So let me just size this up a little better. And you see I'm cutting it where it's in the center of the size of the chevrons for the triangle, left over from the triangle. And so we're going to connect our leads to one side and then the other. And I'll take it down a little bit so it looks more even there. So that's the output of the one side of the resistor, and we're going to come over here and we're going to make the other side of the resistor. So there's a resistor. If you go to try and draw it line by line, that can be real tedious. But just using these triangles, you can do a lot. See, this is showing you how to quickly come up with certain symbols on Paint, which what we're doing now is a form of CAD. There's two types of CAD. Like I said earlier, CAD can be vector-based. A lot of the CAD programs are vector-based, especially the professional ones. Or you can have bitmap. Now, vector allows you to scale with ease, and you can have smaller file sizes, and it's a choice of most people doing. Now, if you can see right here, what I'm doing is I'm going to start a tube, so I'm making the grids on the tubes. And so most of the draw programs you'd use for CAD are vector-based. Of course, if you don't really learn vector-based really well, you end up with a bunch of really skinny lines and skinny boxes and rough numbers. But if you know CAD, you can make these beautiful 3D images and actually come up with a lot of wonderful things in vector-based CAD. Now, in bitmap-based, which is what I'm using now, I'm making another grid for a tube. I'm going to work my way up to a pentode here, I think. And so in vector-based, it's limiting a lot of ways unless you're really learned and are knowledgeable about this system. In the bitmap, you can take off and fly, and I hope you're actually doing what I'm doing along with me on your program and learning how to do all these symbols. You can always pause and take time to do what I'm doing here, and you're learning a lot by doing. So here's a cathode and anode, and I'm going to make it smaller where it's more tube size. And you'll notice that the grids in this tube are not even, so I'm just going to select them all and then drag to the right to even it out. See? So we have a cathode, an anode, and 3 grids. And so now we're going to have to put in the heater, right? So a triangle is perfect for the heater. Now sometimes we draw it where the actual heater is the cathode, but sometimes we actually draw it where the heater is the cathode, but that's one way to do it. I'm doing it another way. It's up to you. And so we're going to put wires coming off of these tube elements here. I'm putting a wire coming off of the cathode, and now I'm putting one coming off of the grid there, the first grid. And so I'm bringing wires out. Now still, I'm not worried about the length because I'll use my selector tool to even them all out. And so I'm connecting to the last grid. And what I'm going to do is sort of unusual on this anode in that I'm going to put 2 connections out because this is a tube that is designed to be used as a template. And so when I actually put it in the circuit, I can eliminate one or the other of the leads off the anode to suit my purpose depending on how I'm going to connect to it. So this is a template that I can modify once it gets into the drawing. So we've got the tube here. I'm going to then use my selection tool to even off all the leads, or actually just drag it over, which makes everything even all around it. And then I'll just cut out all the leftovers. And so all we need to do is put our evacuated glass envelope around the tube, which I'm doing right here. And there's our template for a pentode tube. And once you have a template for a pentode tube, you can easily modify it to be a triode or whatever, because you just cut out the grids. You just cut out the grids and you have your complete tubes between, the 1 grid up to the 3 grids. You can even copy grids and add them in if you want to. Well, what are we going to do for another thing? Let's see what we're coming up with here. I'm going to draw a line straight down. And you start guessing what we're going to draw here. I bet you'll get it in no time. 2 lines now. Now watch how I copy these to keep me from doing a lot of work. So I'm going to copy 2, add it to 2 to make 4. And so I'll put these in here, and then I will bring them over next to the other ones to make them even. Now that I have 4, I can copy them to make 8. I bet you don't have a clue what I'm drawing here, but you will soon. And so I'm going to bring in, so we have 8 lines here, 8 wires, or 8 connectors. Now let's make a box tool. Let's go ahead and pick our box, and let's draw a rectangular box across these lines. Now here's a neat trick. I'm going to take the select button to remove all the lines in the center of the box. It saves a lot of work when you do it this way, and it makes everything even. So, are you starting to see what this is? Now I'm going to draw around it and move it to make all the connections on either side even. Oh my gosh, we have an IC chip now. Isn't that exciting? So I've just made an IC chip, and so if I ever want a 16-pin IC chip template, there I have it. You can modify it for any IC you want to make just by adding on, cutting and adding it on to that. Now let's modify something we have. So here we're going to copy and paste our diode, and so here's our diode. Now what if we want to turn this diode into a light emitting diode? Well, I'll make my line size smaller and then put a little arrow coming out of that diode indicating that that's a LED instead of a regular diode. So here's another template I can use when I'm drawing my schematic diagrams. Get everything even here where it looks pretty. And then I'm going to go ahead and cut out that little leftover I made there. And then we're going to take our diode and we're going to move it into our basket of component images that we can use to design and build anything we want to. Now let's take a look at this resistor. Let's say we wanted to make a potentiometer or a variable resistor. How do we do that? We need to have a center tap on it. So I think the easiest way to do that is to go to our triangle tool, and let's draw a triangle. Of course, this triangle is going the wrong direction and the line size is wrong, so I need to go up here and change my line size back to the correct size, and then I need to flip this vertically. So we'll go to rotate and then rotate vertical, and so there it is. And so now I'll just take that tip of that triangle and connect it to the center of the resistor, and then use my select tool to cut away most of it. And now we have the contactor that's going to our resistor, and we're going to draw a line straight up, and so there's our center tap on our potentiometer schematic image. So that's really cool, and it didn't take long to make that. And see, once you make it, you just make it, you store the file of the image as a bitmap, you know, like a Microsoft bitmap, or anything you could do, a TIFF or a GIF or whatever, you know, whatever keeps your resolution up there. And you can always grab it and use it whenever you go to design something. In a little bit, I'm going to do a tube amp using these components I'm making, and we'll make a professional looking schematic diagram of a 1950s tube amplifier for a guitar. I think that's what I want to do next. Okay, we're going to make another line. What are we making now? Let's take a look. See if you can guess it. I'm going to go in here, and I'm going to select it, and I'm going to cut it. Now what is this going to be? And I'm going to come over here, draw another line. You starting to see what that is? And then I'm going to put a little arrow on this line. If I said it was a SBST, would you know what that meant? I'm going to then bring this over where it's underneath the switch pole. I gave it away, it's a switch. Let's put a little circle here on the end and clean it up. And we will have our switch, a schematic symbol for a switch. Look at that. Didn't take long at all to make a schematic symbol for a switch. And we'll take that and we'll put that in our bin of symbols that we can use forever in our draw program using Microsoft Paint, which is absolutely free and anybody can use it. Okay, let's go ahead and let's make a modified version of our tube. Let's say we want to have a tube that has less grids in it. So we're going to cut that, we're going to paste that, and so now we have our tube, the center of our tube, and let's just remove one of the grids. Or actually we're just going to go to the bottom and move up. So now we've turned a pentode into a triode. Get rid of some of the excess stuff. And also I'm going to have to use an eraser for that one because it's too small. So we'll go over here and we'll expand the view using zoom, and that way we can work a little closer. So now we're going to go back to our home button and we're going to actually use a select tool. But I'm going to show you something different here. I want to make that wire longer. Up to now I've been actually adding wires, but now I'm just using select to extend the wire. Now that's really cool because when you use the select tool to extend the wire, the line's always perfectly straight. I'm going to go down here and make my eraser a little smaller and get rid of that little error on the bottom of that tube that I'm using for the sections to make the other tube. So I'm going to copy this chevron and I'm going to paste it and I'm going to put it down here. Now let me show you a little trick here. What I'm going to do, instead of drawing two lines, I'm just going to go my select tool and I'm going to grab the ends of this and I'm going to drag out, making wires. Didn't work. Okay, let's let go of it and be sure and grab it so there's a little arrow pointing out. Not the 4 arrows, but the 1 arrow. See how that's extending? I drag it some more, it extends some more, and they're perfectly straight. And then I can take and I can even them out by cutting them with the select tool, like I'm about to do right here. Grab here, and we'll do the same thing. Drag it down, and we have wires. Just by taking the tips and moving it. See how that works? And so this is another way of making perfectly straight lines in Microsoft Paint. And I prefer it sometimes because you don't have to worry about getting everything straight. Now we're going to put our evacuated glass envelope with a little smaller size just to show you a difference around our triode tube. And we'll get the select tool and we'll even out the filament leads. And we'll also use the select tool to increase the length of the anode connection. So now we have another tube. We're going to even it out now with our select tool, and we'll move that into our basket of components that we can use forever in our future draw programs. We're going to then move back, and you see, look at all the things we've made in just a very short period of time. Let's make something else. I'm going to do a triangle here. What if you can guess what this is? I'm going to go and I'm going to size it a little differently, and then I'm going to rotate it 90 degrees. Oops, went the wrong way. No, I'm the right way. I'm the right way. And then we're going to cut off one of the corners. See if you can tell what I'm drawing now. We're going to cut off this end, and then we're going to get the rectangle tool, and we're going to draw like that. And now you can see we have a speaker. This is the symbol for a loudspeaker. To make things easier, I'm just going to use the rectangle tool to draw a little box on the back of this, and then I'm going to take my select tool and I'm going to cut off the ends and get rid of this. And so now we have a perfect schematic diagram for a speaker. You can also use this a little bit similar method to make a microphone or lots of other things. Move this right in here. So we've added a speaker to our basket of components that we can use. Now, just for fun, I'm going to use the text tool, and we're going to name some of our components. So I'm going to type in some of the I'm going to type in some of the names of our components. And what I do is I'll type them all into one window, and then later, after I'm done creating the text, I'll then use the select tool to actually move the words to the proper location on the screen. Even though Microsoft Paint is a relatively simple program, if you know what you're doing, you can actually do a fairly good schematic diagram or a block diagram with relative ease once you learn how to really make use of all these tools. You got to remember, your select tool can be used for selecting and moving, selecting and cutting out, selecting and extending, selecting and resizing. So you have a lot of power with the select tool. And now I'm just taking it and I'm putting the names. And if you wanted to do like component numbers, you could do that. Whatever you needed to write by whatever you just drew to, made a mistake. One thing you want to do is not drag it with one arrow, because it'll make it resize, and you don't want that. So, and here I'm putting the IC chip name right in the middle of the IC chip. And now we're going to do the resistor and the switch. And so you can see with this little methodology, I've made some fairly complex components with relative ease using Microsoft Paint. You can do just as good with Mac Draw or Mac Paint. You also have the ability to do colors if you want to.